And here we are to the bench. It took a bit of time because I changed completely the audio setup. It works. Of a delay. Audio. It works. It's a lot better. So since the last stream, I've removed in the audio, there was a really high pitch noise. And I found out that this comes from a switch mode power supply, which was near the UHF receiver. Because I'm using a wireless microphone, I have to get lots of stuff. I cannot use a cable microphone. And because I'm moving a lot, I cannot have a microphone just pointing in my direction. So I'm wearing, let me show you. This is the microphone I'm using, and I'm using to talk to you. And it is connected to an UHF receiver, and the UHF receiver was close to plenty of switching power supplies, and this was what made this high pitch noise. And it wasn't on the audio cable, audio output interface. It was really on the antenna side. So something is radiating, and it was quite hard to find out. But now I changed the location of the UHF receiver, and instead of having a cable which had a lot of noise on the USB audio output, I'm using an XLR input. And this, I remember why I stopped using it, because the setup time is just too high and it doesn't work all the time, but the quality is really high. So this is what you hear, the quality is a lot better. So today we will do a quick hack. I will add it to the quick hack category, and what we will do is, let me get it. I have a soldering station. I have plenty of soldering station, but in this case, I have this soldering station. It's a Quico 1012. You get it for rather cheap on AliExpress, and it's good. I really like it. I use almost the same here. This is I cannot show you. So this is 541 T12 951, and here I have a T12 942. This one has an OLED screen, which I really don't care. I prefer this 7-segment display. But the advantage is it has an internal power supply. This one has an external power supply, and you see you have to feed it 19 volt to 24 volt. But this is really easy because you have plenty of power supplies available from your laptop, for example. Let's stay up. This one. This is from an old laptop. You see 19 volts output, plenty of amps, 5 amps, and you just cut the cable and have the correct plug. So now you have a soldering station, just using a scrap soldering, scrap power supply, and then this module. And the tips, why is it called T12? Because it uses T12 solder cartridges, like these ones, where the heating part is in the end. See this? Yeah, this is my kind of portable soldering station. It is not completely portable, but I will make it a bit more portable. The audio so I don't hear my feedback. Yeah. Off. So what I do have in my electronic starter kit, I've presented it in the dehumidifier project. I did have a soldering iron, which was like this one. This was a USB soldering iron, so you just plug over USB, you have a aux connection, but this is really for small. Oh, I don't need to do this thing on it. Oh, I'll get it off later. This is really for teeny tiny SMD and some small through hole. For soldering cables, it is not sufficient. So the 3 watts here are not sufficient. For SMD parts and for just fixing boards, this is plenty sufficient. And I liked it because it was small. Meanwhile, I found another one, which is in my bag now. It's this one. I have to take it apart all the time, because else it doesn't fit. It also uses these E12 cartridges. No, it's not completely 12, but also these integrated cartridges. And as input E12, it uses 12 to 24 volts. You can set the temperature here. Don't believe on what's written on the temperature indicator, but just have a feel of when it's solder. When it's enough solder, just put it a bit less heat, and when it's not enough, just add more heat. And normally you would have to, like this one, use a USB adapter, a power adapter, and then you can plug it in. But what I did instead, to have it completely portable, I created this cable. And this cable on one side has this part where you just fit in. It says 20 volt. And on the other side, it has USB-C connection. With USB-C, we have power delivery. Actually, it's not only USB-C, but mainly because of USB-C, you have something called which is power delivery, which allows you to send a lot of power, up to 100 watts. Now, for 100 watts, how does it do that? It sends up to 20 volts. This is why 20 volts, and then up to 5 amps. To have 5 amps, you need special marked cable. For EMAC cable, so the standard cable, not fancy cable, is 3 amps. So it's maximum 60 watts, but it's plenty sufficient for such a small soldering iron. And I'm happy with this soldering iron. And yeah, I can show you actually how well it works. So here we have the parts. Let's get a USB-C power supply. And since I'm often moving with my laptop, which can be charged with USB-C, I very often have a USB-C charging station or a USB-C power supply. Reuse this one. And some laptop can also deliver the power out. So let's switch on, and I like this power supply because it tells me the volt output. You don't see because of the reflection. Let me check here. This is the amps output, and it also shows the voltage output. Amps and voltage, and you can set the timing, but it indicates it has a normal USB port for charging all kinds of devices and a USB-C port, which I used for charging my laptop when I'm not stationary, so lightweight. And can you see? Yeah, you see 5 volts. When I now plug in, let's not cheat. When I plug in this supply, you should see it switching to 20 volts, because this small board here is a power delivery adapter, which just uses the power delivery protocol to ask 20 volt from this power supply. And here we have 0 amp, but it should show 20 volts output. Show the voltage. This is the amps. Voltage 5 volts. Okay, that's weird. Maybe it needs a load. Let's put a load on it. Oh, only 5 volt output. Which is not a lot. I don't know why. It used to work pretty fine. So, connect it again. 5 volts. You should switch to 20 volts. But you don't. Is this cable broken? This should be... Oh, this should be fine. This is a 100 watt cable. So this is E-marked. And it doesn't like E-marked cable. I've never tested it with E-marked cable. I'm using another cable. So normally I have this cable. This is not E-marked. This is up to 100 up to 60 watts. So let's try to figure out 60 watts here. Up. Now I connect this device, and I know it worked with this. Switch on. Now it doesn't anymore. Okay, that's the demo effect. I have no idea why it doesn't ask for 20 volts anymore. Because it did work with 20 volts. It's not plugged in. All right. Now it's plugged in. And does it say 20 volts? Can't show the volt. Yeah, 20 volts. It indicates 20 volts. So it worked with a non-EMAC cable, but it doesn't work with an EMAC cable. That's a bit of a shame. So this is not a good product. I'll show you what the product is afterwards. So this is the EMAC'd cable. And now it should switch to 20. It doesn't switch to 20 volts. Okay. It doesn't like cables which have a chip inside with indicate that it's 100 volt capable. So this chip has kind of an issue. That's good to know. But yeah, these cables, I have to debug why. We can try to debug why. We can try. I do have a device which allows us to do that. So you see, I wanted to do something small and now we have to debug why it doesn't work. So my box with plenty, so this is a box with plenty of cables and things to test, lots of things with power delivery. So let's get this one. This is the QAU2 and I made a video out of it where I presented it, and it's a USB power meter, UPM for short. So we can connect input is this. So here we have Type-C input. Type-C input, it should switch on. And it detects, you can also use it as power meter detection. You see here, it's able to do it's supporting protocol power delivery 3.0. It's quite hard to see. Power delivery 3.0 up to 20 watts, up to 2 amps, so 40 watts. And I don't know why, but my laptop, when it is connected to it, it only draws 30 watts. So it's only using the 15 volt output and not the 20 volt output. I don't know why, but it's still enough for charging while I'm not using. It's not really power hungry. So how do I go out of this menu? I want to go out of this menu. Okay. Don't go out of the menu. And you can see that there's an eMarket also. Yep. Let's connect. I also use this device. It's not the only one, but I'm using this device for quick test. My own device. But this one allows me to, it's cheap, it is reliable, and it shows you kind of some information about the cable. So if we go out, doing Chinese translation. This, let me try to have an angle where you can see something without too much reflection. And it's red. Now you see my face. Now you see the camera. Doesn't matter. So I want to exit. Yeah, 5 volt, thanks. Let me exit the menu. I forgot, I don't use it very often, so I sometimes forget how to use it. Come on. Shouldn't be that hard. Okay. Now we are out. This will show you the protocol which is used. And the cable. I wanted to show you the e-marking. So this device also allows you to show if the cable you have supports power delivery 100 watts, 100 amps, because here you have e-marker is kind of the branding, but how is it called? Chip, how it's called in the specification. So it's an e-mark cable. And if you look at eMark cable, then it will ask the cable. So you see, this is connected to nowhere. But within the cable, there are some chips, sometimes one, sometimes two. You can have chips on both ends. They are quite small, and they tell you the capabilities of the cable. If you want 5 amps, you need this cable and it needs to advertise 5 amp. And this is what you see here. It says current capability up to 5 amps and the length of the cable 1 to 2 meters. I don't think it is true. It is probably true, but very often I find a lot of cable where this is not true. They just use a default value because they have no idea which cable they use. They just put the chip and then the cable they didn't know. But at least it tells that it supports 5 amps. When it supports 5 amps, the thickness of the strands here should be higher, should be bigger. If that's true or not, you have to cut the cable. But at least this will indicate if this is a 5 amp cable or not. And if we take another cable, so this one, which is a simple cable, we connect it, you will see that it detects nothing. It does some auto refresh and auto clear, and here detects nothing. This cable is not E-marked. Now, let's check what it does. So let's go out of this E-marking. How do you go out? Back. Okay. Let's connect the E-mark cable to the power supply. Up. This is the inputs. And this way we can check what it does on the output and so on. I have to switch here, pass through. Here you have to change the switch because here the power delivery. If you put it to off, it passes the power delivery through the device. Else it does check the power delivery itself, and whatever is on this end or the output end will not be able to talk power delivery or to talk this to talk the protocol. And now if I connect, it should ask for 20 volts. So this chip should ask for 20 volts, but it doesn't. Not with the marked cable. Let's try yet another cable, you see, and I need plenty of USB cables simply because of that. Testing. I do have other USB cables, USB-C cables. Up, USB-C. So this is only 3 amps. Okay, this is longer. And I mark cable. You see, USB 2, only 3 amps. 3 amps means it's not marked. Well, it can be marked in 3 amps, but this is very rarely the case. And if this would be the case, I would have marked that it's 3 amps, but marked. Okay, so we switch off, switch on, and we check if now it can. You see, now it asks for 20 volts. Okay. This chip inside here is not capable to talk to use PD cables. That's really weird. With non-PD cables, it works perfectly fine. That's a flaw in the chip. We will have a look at the chip. So what? Yeah, let's first finish this and then we'll have a look at the chip. So once we have 20 volts, repeat reflection. This way there are less reflections. Yes, once we have 20 volts, we can try to power it. And the connection is bad. What is going on? Connection here is bad. On. 5 volts, switch to 20. On, switch to 20 volts. It's restarting all the time. Maybe it doesn't like. Oh, I don't know why it doesn't like. I think this cable should be able. What else? I do have a smaller one. Here, this is a tiny bit smaller, and it goes in between. When you connect, this small device. How do I do that? Yeah, here. Connect this small device on. hope you're not feeling too dizzy because I'm playing with the cable. Now it shows nothing because it is not on. As long as nothing is drawn, it's not on. As soon as we plug power, it should switch on. It is switching on, and then it is telling. I don't know why it doesn't work with this one. And it heats up this cartridge. Well, we can do a test how fast it switches on, but this is pretty good. So let's try with the marked cable. If it also doesn't work, this is the marked cable. Up, up. Yeah, with the marked cable, it stays at 5 volts. It doesn't switch to 20 volts. This chip has an issue. I will have to mark it on the chip. I will mark it right now. This way I know in the future that it has an issue. And how do I mark it now? Yeah, I don't have a lot of space to draw it. I could add here. I have this thing which tells me that it will be 20 volts, and I can mark on the back that it doesn't work with PD. Does not work with amp slash electronic marked cable. Okay, it's written for the future. I will know what the issue is. Let's try to. Well, now it is still a bit hot. Oh, I can feel it, but we can just show you that it goes pretty well. So this is switched on. Let's have some solder and up. Give it a bit of time, and you see it works perfectly well. I can recommend this portable USB soldering iron if you have USB-C, if you have either plug, or if you can use this USB-C chip. Now let's have a look at the chip. I don't use this anymore. You can heat. I don't require this anymore. And I did have some additional, so I made this cable myself using just DC barrel jack and one of the chips. And these are the chips. These are the cables which are here. You can buy them. So in power delivery, if you use power delivery 3.0, you can ask for 9, 12, 15, 5, 9, 12, 15, and 20 volts. If you do power delivery 4, the protocol, there is something which is called PPS, and it allows you to increment by 20 millivolts. So it is a lot more smooth. But most of the things don't have power delivery 3, 4 and support PPS, and this is plenty fine. So this chip is an IP2721. Will it be able to focus on it? Yes, but you won't be able to read it. Or maybe you can. Here, IP2721. I had this for longer. Maybe they changed. Maybe they changed it. Maybe it works now with power delivery cables. So let's try it out. Up. There is paper inside here. Let's remove this. Long tweezers. Oh. Cable is gone. So we need this device so you can see what it does. We don't need this cable anymore because this is for the old one. And we will try first with the non-marked cable and see what it does. And here it should switch on. It does switch on and it should ask for 20 volts. It does ask for 20 volts. This works. Let's try with the marked cable. Maybe they modified the firmware in the chip so it works with marked cables. This is a marked cable. 5 amp, 100 watts. And if we connect this small device, no, it doesn't. That's good to know. So this chip is not as good as I expected. It doesn't work with marked cables. I have to, and also this is, I bought it not too long ago, 1 month ago, something like that. And you can buy them with plenty of configurations, as you can see here. You can buy them with 9 volt, 12 volt, 15 or 20 volt output. This one, I bought it with 20 volts or 20 volt output. And the purpose is that we will put this device in here. And this way I can either power using this normal DC barrel jack, or I can power using USB-C. I want USB-C. Because this version is somehow thought to be portable. Yeah. So this will be our task today. Put this chip, which does not support marked cable, into this device. So it's a quick hack. Shouldn't be taking too long. But we know, and I didn't know that they didn't work with marked cables. So this is already good progress that we made today. Up. So let's open the device, and it's rather simple. This device, simple to use. This device, this soldering station, and I can recommend them. Sure, I have other soldering station, but this is the same unit almost as my second soldering station, which I used for second soldering, and they are plenty enough. They do plenty of power. So you have to provide, ideally, you have to provide 24 volts because it just switches on and off the voltage. So the more voltage you have, the higher, the faster it gets warm. And you see on the inside, just input going to the switch, and this should be a red cable. I don't like it to be black, so we will change it to red. And then going to the board, and the board here is simply a microcontroller. See, STC15F20 or AE, and yeah, this is probably some EEPROM, also temperature, some temperature. This is a temperature couple, probably. This is the switching MOSFET, so this simply switches using PWM the power to the soldering station. That's why if you have higher voltage, then you will have a faster heating up soldering station. And this microcontroller just takes care of controlling the 7-segment display. So nothing fancy, simply secret. We could even have this a lot smaller by not having this this case and just having a sleeve. It would be a lot smaller, but it's good enough and it is robust. So I will keep the case. Yeah, I will keep the case. So what we want to do now is add USB-C, and we will add it here. We add it flat. Yes, we will add it flat, and there's plenty of space. Add. Up. Let's mark where we want to drill. Then drill. White pen. We can use this module, or we can use a USB-C cable where we want to mark it. Fine. Something like that. So I think what we'll do is first drill it and then fix it. So we will use the power drill because it is still 1-2 millimeters thick aluminium. Do I have something small enough? 3 millimeters, a tiny bit too small. 4 millimeter would be better. 4 millimeter? Yes, 4 millimeter looks nice. So I will do it with 4 millimeter. Up. Let's put wood. If I want to have it completely flat, I would remove the rest, but it's fine this way also. It's a quick hack. And the drill. Up. Drill. Also, this drill bit has the part for drilling and the part for cutting on the side. I've never used it, so we can actually use it. I'm not sure if it works really well though, and I have kind of some doubts, but since I'm working with power tools, up, gloves, and eye protection. Gloves, eye protection. Dun, dun, dun. Up. Gloves here. I will switch off the audio while I use the power drill so it doesn't hurt your ears. See you soon. This aluminum is really soft to cut, so I didn't need to apply a lot of force to it. But now I want it to have to be kind of aligned, and that's why after the first hole, the second hole will be tapped. I'm using a center punch, which doesn't work all the time. It's kind of annoying, but yeah, I need to clean this hole, but that will be done afterwards. So the center punch, center is around here. See, doesn't work. Now it works. And what it does, it just, oh, it's maybe a bit too large, isn't it? No, it's okay. It's large, but let's have a center punch next to it. What it does is just add a tiny dent in the aluminum or in the metal, so your drill bits can center to it. Ideally, you would have small drill bit and then go higher. Here it's not. So let's drill the second hole. So here the first parts, it is not very straight. We will clean it with smaller drill. I should have used a smaller drill and enlarge it afterwards. Too much of an issue. Yep, we want to be quick and efficient, so let's get rid of this. And I've used the sides thing here, and it worked okay. It's not that precise though, but it was able to cut a bit of aluminium. So to clean up, we'll use something else to make the hole up correct. So we will use, damn it, broke again. Ah, I hate it's my fault. I did not pay attention. So we will use the high-speed rotary tool, or most of you know as Dremel, but it is not a Dremel because it is a Technic Pro. It's plugged in. Up, and we will use something to cut metal. Here I have some engraving bits. This is meant normally for engraving and cutting in hard material. Okay, let's try this. Mandrel. This looks fine for side cutting. I've never done a lot of side cutting. So let's try it out. And this is the wrong parts. This one larger. I don't want to change. No, I have to change the head. Because the shaft is not the right one. Yep. Here are the tools. With a smaller shaft. This one. So change the grip from large hole. And yeah, I broke a disc. But yeah, consumables. Still annoying, but it's just consumables. Let's put the one for the smaller. And grinding. Maybe we could use a grinder, but I will try. I don't know which is the right part. I'm not that much of a materials guy. We will use a kind of vise. Wait, not to move too much. Ah, I should have actually. Oh, you see, they even added a shrink tube, but they didn't shrink anything. We will add shrink tubes on all of the connections. For example, this one broke. We'll add shrink tube here. And yeah, it just acts as a strain relief. So let's put this inside. And I will try from the side to make it kind of flat. I will switch off the audio for you not hearing this high pitch noise. Okay, and I'm surprised. It worked quite well. You see, it is not perfect, but the rest should be done by hand, and we'll do it by hand, removing these files. I do have a deburring tool, that's the name, which should remove the burrs out, and it kind of does. Kind of do it on the other side too. Looks nice. Oh, now it is not large enough. I was afraid it was too large. Now it's not large enough. Ah, it's high but not large enough. So I'll have to use the grinding tool. So let's switch off. But this time I will also wear some ear protection, because it is loud even for me. Ear protection done. And I will switch it off also for you. That's why you wear ear protection, because what you just see is that this was flying out at a very high speed out of it because it was loose. Although, oh, this high speed thing, I can't put it in again by hand. I don't know how it slipped out, but due to vibration, it did slip out. So let's use, yeah, so eye protection, good thing. It didn't land in my eye though. It landed just to the next bench, but who knows what could have happened. And let's continue. Now it fits up, but I scratched a bit. But since it's anodized, you see how well it fits. Since it's anodized aluminium, We can cheat a tiny bit. And where is my marker? I used the marker a couple of minutes ago to mark the cable. And normally when I use something, I leave it on the bench here. I have it. And if we just paint it, we'll see no trace anymore. See, nothing happened. See it with certain angles, but else quite well covered. Tools is there to be used. Tools are there. The issue I have again is I put it here. How do I hold it in place? And yeah, the only solution I have again is epoxy, 2-part epoxy. Plenty of it. And now what I like with USB-C also, you don't have the holes in you don't have the holes in the cable like with, let me show you, USB connectors. Here, on micro USB, it's a bit harder to solder, to put some glue, to glue down the connector, because you have these tiny holes, top and on the bottom, where the cable clamps into. These are not in USB-C, because it clamps using all the brushers inside. There are 24 pins, so there's enough force for the 24 pins to hold well enough. But it doesn't have this nice feeling that it's really holding as well as with your micro USB. Micro USB meaning this is USB. Actually, the correct term would be USB Type B micro. USB-C, the correct term is USB Type-C, the connector, and it just has been shorted to USB-C. And even the specification, I think now they call it USB-C instead of USB Type-C. Although in the beginning, it was really called USB Type-C. And I think the old ones, USB Type-B, is still called USB Type-B and not USB-B. So, kind of a mix and match. I lost a screw. 1, 2, 3. Did I just put it in the trash bin? I think I have these kind of screws, but it would be nice if I didn't add it to the trash bin. Let me have a look at the trash. I didn't feel it in my hands. No. There's nothing like this here. Should put more attention in what I'm doing of telling stories about USB, and I think I do have. Yes, I did lose it, and I put it in the trash, but I won't find it in the trash again because the trash bin is quite full. Do I have these screws? I do have plenty of screws. I do have of it. Is it M2 or M3? I think this is M3. Is it not here down? No. Not sure if I need the vise again. I have M3 screws. Bag full of them here. But they're not the same head. This is a crosshead. These are not crosshead. These are the sort of hexagonal heads. They would fit though, but it would be nice if I would find the screw again, not have used a new one. Yeah, I think I put it in the bin because I don't see it anywhere else. Oh, I do have some of the screws. Maybe they're long enough. Yeah, they seem to be long enough. Yeah, this bag of screws, so I can use this one. Check the bin. Is it easy to find? No, there's so much stuff in there. Nope, I won't find it. I will just use a replacement screw. For now, we need to mix some epoxy. This I don't need anymore. And yeah, so what I should do and what I normally do, but I'm distracted because of you, is use a case. Oh, microphone was too near my mouth. Use a case. Like this. This was from the previous marking. Let's remove this because this is not applicable anymore. And in this case, I put the screws so I don't lose them like I just did if I do contract work, professional work. So we'll do the same here now. Yes, no screws anymore. Yeah, got lost. Yeah, happens. This, we put it, the second chip, we put it back, we don't need anymore. Ceramic. This was a ceramic protection. Now we need to, I don't know if I need, we'll put it here. I will clean up the hole using a round. Do I have a round one? Yes, I do. This is round, yes. I'll clean up the hole using a round file. This aluminium cuts like butter. Really simple to cut. It's really soft aluminium. Not sure if it's cheaper, but it's really soft. Part epoxy. I have a sheet of paper I don't use anymore. Yeah. Up. And this is quick one, which dries within 5 minutes, so we need to be fast. At least we will have the results also fast. Up. And let me think about a way to hold it in place. Ah, it holds in place by itself. We need to clean this. And I think I can, is it? Yeah, I think anodized aluminum is rough enough. I don't need to roughen it, but use some 70% alcohol to clean the surface so the epoxy can somehow stick to it. Okay, the issue is when you plug the cable, you put some force, and I hope that the force is just not too strong and doesn't put this outside. We will test, we will see. Now we need to mix plenty of epoxy. One part is coming out, like always. The other one is not coming now, but it's coming later. Here, one part, the clear part, is yet out, and the less clear part, the yellow part, is slowly coming out now. Let's put it on the side, and then we will mix it together. This gives me a bit of time, but it is only slowly coming out. It already smells like epoxy. It's oozing. It's not equal parts yet. Should be equal parts. I'm sure it. Not sure it will become equal parts. Good enough. Put the cap on, back on, up, and now mix the two-part epoxy. you think it's ready, continue stirring it at least for as much so you're sure it is well mixed. Now we have some epoxy. Let's try to apply it. And use second one to apply it a bit better. I like these toothpick. Inexpensive, not conducting, not too hard. So it's ideal for patients and for plenty of other things. Ah, I know what I can do. So let's do it this way. Let's plug a cable inside so it holds. I can hold it from this side. Oh, the epoxy is already getting hard. Let's not waste time. Come on. It's bad application right now. Brush. Ah, this is stringing already. It's not glued in. It's not gluing. I need to add more epoxy. It's glue. But it's getting hard really fast. The epoxy is getting old. The best one to apply epoxy on this device. We will need to add a second layer. Doesn't look too pretty, but I hope it holds. We need doesn't. It's hold to the plastic. We will add plenty of hot glue also. But I'm sure the epoxy is not good enough. Yeah, it doesn't stick to the aluminium as I wanted it to. So let's leave it to cure. Meanwhile, I get a hot glue gun because I will add plenty of hot glue. How do I hold this? I don't have things to hold it. Up, up. These are tiny clamps which are normally thought for mobile phones. Fixing and repairing mobile phones. Okay, let's leave it there for 5 minutes until it dries, and let's get the whole glue gun. And I'm sure this will be enough. This glue is not very good. But yeah, I didn't buy a really good glue. I need to get a new one. Actually, I had another one, so this is my rescue glue. I had another one, which I gave to someone for a tiny project, and he somehow forgot to give it to me. Forget to give it back to me, and that's why I don't have it anymore. Meanwhile, let's put the parts back together where they belong. Screwdriver. Shame I lost the screw. I don't need this anymore. These are not used. Back. This. I don't need this USB soldering iron. Up. This can go back. This is really tight. Can also remove the eye protection because the vision is not as clear. Up. Up. USB connectors, they go here. There are screws, we're not done with it. This goes here. Up. Meter, we don't use this anymore. Yeah, it looks halfway straight. It's okay. But I think it's not ready yet. I don't have enough things to clean. Meanwhile, this way, I have too many things to clean in the end. Up. Up. The power delivery cable, I need to get rid of it because it doesn't work for our case. I can put it back in my USB-C box. I add the USB-C box. USB cables, where are you? Yeah. I should have tested it before I glued it in electrically. Great. I think it's fine. It will probably depend on what power supply you're providing, but 40 watts would be sufficient for it. It asks for 60. It was written 3 amps, and I have a lot of things which are not able to provide 3 amps. I still think it will be fine. Even if it can only provide 2 amps. The rise temperature, the soldering iron will not be ready as quickly as before, or as quickly as you would like it to, but it will slowly ramp up and still work. Up. This is done. This, and there was something else. This. I think it is. This is just cable. This witness shows that it is getting ready. This is already hard. It is soldering really quickly. What I didn't test it is using, you can have power banks, I see plenty of power banks, and a small power bank which is able to deliver USB, but I think only 12 volts and not 16 volts, but we'll try it out. But you have power banks which are able also to deliver 20 volts. I meant 20 volts. Cluck, cluck. Up. This is clean. Let's check if it is solid. Not completely, but good enough. I don't need the power protection gloves. This way I have a better feeling on my hands. Up. Or in my fingers. And now we can also start soldering the things together. Up. Soldering iron. Cable. Water for the sponge. Soldering iron heating up. This is warm enough. Should be okay. For unplugging, I have no reason to doubt that it works. Just for plugging, I'm afraid it won't hold. Clamps, get rid of them. Clamp. Not very straight. Not too important. This is hard. This is hard. Kind of hard, not completely yet. Not very straight. Before I put hot glue on, let's try to see if it works. So you cannot see the output. There's nothing. I now connect. See, we should have 20 volts. And now if I measure this here, oh, what I also did yesterday in the stream, we saw that my dashboard didn't work. I couldn't read the measurements anymore. Now I can. Let me show you. And the issue was, there was an issue with the serial, with somehow serial ports, and the issue was in libsgrok, no, not libsgrok decode, but in libserial port, which is a library by Sigrok. The 1.1 has this issue, but the Git version, 1.1 is the latest release, it's 5 years old. The Git version doesn't have this issue. I just had to compile and install the Git version, and now it works again. And let me enable the multimeter again. Soundtrack. UT up the multimeter. Okay, it's able to read multimeter. Home automation. Let's go to my dashboard. Power consumption bench. We are measure here. 1. There's plenty of water on my desk because the bottle is sweating. This we don't need anymore. Here, the multimeter. Now you can see the measurement again, and if I connect the multimeter, I can still zoom in more. This should be enough. How do I think it's this way? Yeah. You don't have the banner. And now test it, which is plus, which is minus. This is plus, this is minus. We have 20 volts if I don't touch the glue all the time. Rid of the that. So, is it 20 volts? Not 20 volts. But here also there's no output anymore. Switch off again. Ah, I hate these power supplies which switch off when you don't draw anything. $20 volts, 20.2, as the display says. This one. And now it's switched off. So if you don't use any voltage immediately, it switches off. Is it with all power supplies or it's just with this one? Get another USB-C. And I think I have a USB-C which is not able to deliver 20 volts. Yes, let's see. This one doesn't deliver 20 volts, it delivers up to 15 volts. Let's see what this module does. If we can only deliver 15 volts, does it still ask 15 volts or does it do nothing? Because it is spec'd for 20 volts and yes. You see? It delivers 15 volts. What if it cannot deliver 20 volts, neither 15, but only, I think this one is only capable of delivering 12 volts. Will it still continue trying to provide 12 volts? Yes. So it uses always the maximum. And I'm sure that if I don't have 12 volts, but only 9 volts, it will ask for 9 volts. I'm not sure if this is a good design because I bought this chip for 20 volts. If I don't have 20 volts, well, in this case, it's fine having lower voltages, but in other case, it could lead to brownout and things like that. Wouldn't want to have. That would be not good. This one, yeah, 15 volts. And so let's use this power supply. This should be 20 volts USB-C. Up. I think it's 20 volts. We will see 20 volts, yes. And that works. So now we can solder the cables and we can put the glue on, and I will clean camera movements. I will clean this soldering. This one needs to be red, not black, red. So we will remove this, we will put red, we will clean this one, add it here again. This is not how you solder on the tab. There's a hole, and the hole is there for something. This. Pair the cable. Where is my plier? This is done. And how you solder on hooks. Let's put some shrink tube on it before. Shrink tube, plenty of it. Should be enough. Don't forget to add the shrink tube before. How do you solder on these things with the hole? Make bend the cable. Solder the bent cable in the hole. This way you have connection on both sides, and there is added strength. That's a better way to do it. I'm not sure if it's the best way, but it's a good way. Better than what you did before. Okay, now we have plenty of solder both sides. Shrink tube, up, hot air gun, 200 degrees Celsius. Heating up. Oh, I should try, yeah. I can't try it. So let's try this first. Shrink tube. This adds a bit of a strain relief and it looks cleaner. Switch off. Now we need this cable. I will remove it. The wrong color. This is plus. And same issue here. They didn't add it in the hole. Let's remove the solder from the hole so I can have access to it. Using soldering pump. Oh, it doesn't. No, it does have a hole. Okay. It does have a hole. So, oh, I could have. I should have, and I did not. Here I need to connect the ground to this lead also. So there will be no shrink tube, but gotcha. Move the shrink tube, and we will have to add another cable going from here to here. The problem here, the hole is too small for the cable. I'm using AVG cable, AVG20 cable, because it is really thick silicon cable, but it won't fit. Oh, it does almost. I use AVG22, then it should fit inside. Two minus 3. Something wrong. Wasn't able to pull on the cable. So can you go inside the hole? We could add surface solder, but it's better if we add it from both sides. This adds strength and reduces the contact resistance, so we can put more amps. So the surface is really small, so it wouldn't matter too much. This I have to desolder it again. Pump out. More. Stop moving. Another tube. Up. Oh, sorry for the camera. Bump. tube. This cable. Put the shrink tube also here. Cut it somewhere here. And the shorter it is, the less resistance there is. A bit of flexibility. We don't happen. Fine. That I can use. See. Both cables. Really ugly. Prepare it again. I will. Cut. Prepare it again. This way we won't do it correctly because we have two cables. It will be hard to do it correctly. With the lead, with making a J, but we will put the lead through still. So you twist this cable. I just broke the red. Fix that. And I cannot put it through the hole. It is too large. So I will need to make it surface. Take it to the surface. Let's tin cables. Won't be beautiful, but it will hold, and shrink tube will make it hold better. I have no choice. I don't have a third hand. Plenty of solder. Plenty of solder. Well, now we can slide it, or try to slide in shrink tube. Up. Tube is in. Warm up the shrink tube. That will hold. That will hold good enough. That's the first one. The second one, actually, the second one we need to solder here, or we can solder it here, and I think we will solder it here. So we also need to clean this part. Okay, clean. I have red shrink tube, but not large enough for what we want, and also not for this step. This I will have to use my 5mm shrink tube, and I have a second drawer for that. This is 5mm. Yeah, 5mm shrink tube. 5mm is enough. This is the stream you see not very clear now. On my screen is very clear. How do I open the exposure on this device? Menu. It's still good enough for you to watch. So look at this cable. And here we get the J connection terminal because I only have one cable which fits well enough. Not yet. Wait your turn. And I like this soldering iron because they have a lot of power. Even with this huge terminal, I can really solder well to it. And this is an OK Metcal production based. I was lucky to have it for not a lot of money, only 70 euros, because it was broken and it needed to be tuned. Really powerful. Shrink tube 1. Let's shrink it. It will not shrink it. Whoops, sorry for the bump on the camera. It will not go on the cable, but at least on the tab and on the cable it will kind of also give some stress relief. But as you see, it is not perfectly matching the cable. And now we can add the plus, and we will add both plus from the DC jack. And I've seen, yeah, this is nice. This way, having a solder jack is quite nice. DC barrel jack. I need, here. This will ease my life a lot better. Well, there will be a lot of glue on this part afterwards. Camera movements. I can better see what I'm doing. So normally how you do, you heat up the well from below, which I won't be able to do, and then you put the cable this way. Like cable, you come this way. Glue gun, you go on the side. The well below, heat it up. I need to tin the cable first. This is a multi-stranded cable. There's a lot of issue tinning. It will not be able to tin. Insert it in the connector. Let's try again. Yep. Below. Set the cable. Let it cool. Here there's no shrink tube. That's not an issue because we will get it, add it now for both sides. Okay. Shrink tube. I need to buy a new 3mm shrink tube. Goes so fast. To make 2 of them. Up. You go here. Heat it up. It is really not necessary to have the shrink tube, but whenever I have power, I like somehow to protect it. So on minus, it's not really necessary because everything is connected to minus, the whole shell and so on. Up. Now we need this one and the other one. We need, and here we will be able to put it through the hole. But don't forget the shrink tube first. Five millimeter shrink tube ready. I should have moved this mat a bit clear. But now, so we need to prepare the cable for the other side. A little bit thinner, so it goes through this hole. Does solder it. So now, just normally it's AVG20, so it's this size of cable. What I did is I cut with AVG22. It makes a thinner cable, but just for the connection. The rest is still AVG20. And we cut it here. AVG. Right. Pin them together. Clamp to hold them together, and for that I use valve closing. So it's like they're reverse tweezers, because you have to push to open and not push to close. Up. Done. Don't forget the shrink tube. Now put it through the hole. Does it? No, it doesn't fit through the hole. Oh, thought it would, but it doesn't. Solder it on top of it. Damn it. Oola. Who's this? And that should be done. Test electrically, and once it's done, we will add a lot of hot melt glue for this to hold even better. And then done. Let's warm up. Plus points. Now, because this cable thicker, will fit to it. Up. So here is the soldering iron. Let's connect the lead. Okay, leads are connected. This is the front. Let's see if it works. Now we're in position off. I connect the cable. The cable should tell that it is 20 volts. Now if I switch on, where is the soldering iron? Okay. Up. If I switch on, should switch on the soldering iron, and you see it uses 3 amps. And the soldering iron is heating up. You see the temperature, and it's rising okay. Rising good enough, actually. Up 300 degrees. The lower ends, but you can still increase. And if I clean up, I put some water on it, you see it decreases a bit, but it increases really fast. And we have a USB-C soldering iron. Well, soldering station. I did have an USB-C soldering iron already. So let's cool it off. This is still 20 volts. This is a success. We did the modification. Now add plenty of glue for it to hold even better when I insert. USB-C connector. There could be a bit of force. Let it cool off. Wait, so that's one side. The side. Oh, you don't see it. Up. Side. This doesn't matter too much. And then we will add also on the connections. This acts as a shrink tube so we don't short plus and minus easily. Anything is rattling inside. And I need to cut a bit. I need to remove this bit because else I won't be able to close the lid. Up. Let's wait until this dries, and we can help it drying by just connecting a fan on it. Up. Would be better if I have some. I do have some 12-volt output, but this doesn't have some 12-volt jack. Nice to have a 12-volt jack. Do I want to build one? Do I have one of these connectors? I think I do. In my power cables, yeah, I do have plenty of them. So these are, yeah, called, well, everyone calls them Molex connectors. Molex is just brand, doesn't tell which kind of cable it is. Don't I have one which isn't already cut? Oh. That looks too good. This one looks bad. One looks good also. Let's give me one with just one connection here. So we will use this connector. Have 12 volt going through it. Up, cut all the cables. We won't use both of these, but we leave them. We never know. Maybe we will use them at a later point. Oops. And I need to add barrel jack. Here my box of barrel jacks. Here there's a white one. Color doesn't matter. It should fit my 12-volt outputs. Where is my 12-volt output? Should be lying around here somewhere. That's the one. It is stuck. Ah. Stuck. So this is my 12-volt output, which is coming from 5 volt actually. Does it fit? Fits. Let's keep the glue gun on the side and let's keep it warm because I don't know if I will need it. I will need even more. So the idea is to have this connected here. Then we have 12. Can connect the 12 volts. Up. One. Or there's not a lot of strands in this cable. It is quite thin compared to this cable. There's not a lot, but it's still enough. Oh, there's more. Did it the wrong way. Oh, there's not. We can use a smaller shrink tube, can we? It is quite large. This fits. It's small shrink tube. 1, 2. And do we add a third shrink tube for the overall? Yes, we do. Looks cleaner. Come here, 5mm shrink tube. Overall. Actions. Now let's solder the cables. Ah, the glue is already set. You see it is not transparent anymore. It is opaque, meaning it is finished. So we were not fast enough. Well, we were not fast enough. I will still make it, so next time I'm fast enough. Where is my third hand? I should have a third hand on the bench all the time. Seems I don't. It's getting messy on my desk. Third hand, let's come here and hold. Oh, don't forget to do tubes. So, let's pre-tin the cables a tiny bit because it makes it easy to solder. Costs time. Makes your work easier and minus to minus, plus to plus. I was afraid of it getting too warm. Oh, it's okay. Still able to move the shrink tube enough over the cable. One and next one. Oh, it's hard. Move the shrink tube. Should add some lube on the cable. Okay. Shrink tubes up. Let's shrink them. First thing, let's put the lamp. Before we do that, let's test if it works. Yeah, let's connect this. Let's connect the 12-volt output. The fan works. It works. Now we can really shrink this part. Okay, that's done. So now we have a fan for next time. Go out of the way. Project is finished. Now I need to put this back in and have the final tests with the case closed. And not all the correct screws. Can I close the case? Really good question. And the answer is hardly. The answer is okay. I can. So let's screw it together. Screwdriver is here. Long screws on this side. Force. One. Two. 3. And one of the screws. I hope they're long enough. Need one of them. And 3. They're long enough. Let's screw them all because they were just loosely tied. Up, and now we can test the soldering iron again. Where is the hot end? It's to burn everything. Can switch off this soldering iron. Big one. Here's the hot end. Let's put it somewhere where it's no risk. And let's try USB-C and not USB-C. So USB-C, now it's off. Here you can see the power output. USB-C plugged in, 20 volts. If I switch on, it works. And the temperature is rising. And let's try the normal power supply. I still want this one to work. Let's connect the power supply. Yep. Yep, this is very beefy and this should heat up even, although no, it's 20 volts, so it shouldn't make a difference. And connect this. Won't damage, even if the 20 volts are going here on the input of this, it won't damage it. Also, if I would be curious, if I now connect this Yes, you see, it feeds back 19 volts. So you have to be aware that when you connect this and with back into USB-C. So I will mark it. I will write on it that it feeds back. Up. Let's switch it off, and the project is almost complete. We just have to mark everything. So sort of dents, we can close the dent with marker, so it doesn't look this way. And now I have to mark that it doesn't support e-marking. This is too large. I don't have any small white pen. I need to buy a tiny white pen, a very thin white pen, which works well. Don't know if it exists. White markers, do they exist? I only know this with this kind of color. It's large and it doesn't work too well. I have to think about it, but to try to find, we can still put some painter's tape, just kind of paperish, and we can mark. Yeah, and we can mark and write no how they call it, e-cable, e-mark cable. No e-mark cable. Ah, no e-mark cable and tension barrel feedback. Barrel feedback. Now I know that there is a risk. And below here, I can mark S the power delivery 20 volts. It can go up to 20 volts. This is clear enough. And with that, our project is finished. And this soldering station is now really portable. You'll need a USB-C power adapter, but if you have that, which is getting very common, have a USB-C portable USB-C soldering station, which is quite nice with the temperature in the front, and else you can still buy the other ones, which also work quite well. With that, the product is finished, and I will end the stream. See you for another quick hack, which only lasts 2 hours. Bye bye. Enjoy.